Fingers crossed you can hear me. Let me adjust myself. Go back. So, Dan, can you hear me? What's the levels like? Seeing as we started last week a bit quiet, I've put the levels up a bit and hopefully sounding a bit better. I might post that I've gone live. Do that. Just gonna do a little NG social post. Let's do that. Thank you, Dan. Okay, let's get back into it. So, just a quick recap in case anyone is watching who hasn't been here before. This is only the second time I've been streaming this sort of stuff, but let's carry on. I'm Sam. I've been building procedural tools for a long time, and I thought it'd be good to show off some of how it's done and how all the tools I've built work. Last time we built base procedural functionality to create this space station room out of a asset pack I got off for Fab, and today we're going to look at a bit of tidying up, a bit of a preview of some new features, and to help with editing. And then I was thinking of looking at the floor, because at the moment it's very regular and we've got some nice interesting floor pieces to be using. Sorry I'm late this time, something came up at the last minute. Yeah. Oh, right, where do we start? I was going to tidy up a couple of issues with this that we had from last week. A lot of it was basically the simplest possible solution kind of scenario. So there's a few rough edges which we can improve. So one of these is the fact that the floor and the floor doesn't line up properly with the wall, either at the bottom or at the top. There's some other problems we're going to have to deal with if we fix that completely, but we'll come onto the floor a bit later probably. Another one is there are no corner pieces. We've just got the walls fully intersecting. We open up the feature for this and just turn off the ceiling for a minute. That one. So we can see we've got some intersection going on here. In theory, they should be pulled back and there should be a custom corner piece in there, which I think the asset pack has got some nice pieces to go there. So we'll look at that as well. I'm going to get rid of these for the minute. Need those. Come back if we need them. Another thing that's worth pointing out, at the moment as we change the size we get gaps here, because it doesn't do any stretching to fit. It just does it just fits as many as it can, so there's a big gap until you get enough room for the next piece to go in. There's a couple of ways we could solve that. We could start introducing stretching so that it would stretch what it's chosen to fit each time, or we could just only allow rooms of multiples of some number of pieces. At the moment I'll probably go with that solution. I think we can just do some changes to make it, regardless of the size you set, it'll round down to some whole number of wall pieces. We do then have to take into account the corner size as well, but we'll deal with that when we get to it. So I think the first thing might be that. I also noticed that it's not terribly smooth updating, and I realized I haven't got mesh instancing turned on, so I'm going to turn that on. Now we should see it's a lot smoother. It's a lot faster to update. This is a plugin feature. If you don't have that on, it will use mesh components added to your actor. Hey, Null Pointer Games. Good to see you. Listen, that's Tom. Hello. I don't need to reply in the chat. I can just say hi. Good to see you. Hope you had a quick chance to catch up with the first stream, which on YouTube now. But if not, I'm tinkering with procedural space stations. We'll see, and we'll see how it goes. What was I saying? Yes, so we need to fix. I was going to fix that. That's probably a fairly straightforward thing to fix to start with, before we get onto heavier things. But we'll have a look at that first. So if I put that up there, we can see that. Back to the procedures down here. At the moment, we take the input frame, which is the bounds, which is set in the properties here. You can see that's the bounds there. It's actually drawn as a black outline when in the viewport when it's selected. So that helps you see that. So that bounds is then split up into, or has the two sides split off in both axes for the walls to go in. We've got these wall rows here for each of these 4 pieces. I chucked in the floor grid just to give it a floor, and there's a ceiling grid here which I've temporarily disconnected in the way for working with things. Yeah, welcome. We've got a few people watching now. Welcome everybody. Any questions, chuck them in the chat. When I notice, I will endeavour to answer them. But it can be background, it can be currently what I'm dealing with, anything really. So yes, this frame is some floating point value in size, but we actually want to quantize that to some multiple of this this wall piece. I think is 4 units, 4 meters. So we'll do that first. There are different ways of doing that, but we do have a bunch of maths operators we can look through. I think the simplest solution might be actually what I'm going to do. I'm going to create a little procedure to do that, just because it's not something that happens out of the box. Let's do round. Let's see if that's a good idea. And the simplest way to do that probably is divide by. So we've got our value, and we've got our step. Good idea. A bit like snapping, stepping, quantizing. We're gonna do a floor of that, so it's basically snapped to integer intervals, and then we can multiply it back up. I mean, there's probably better ways of doing this, but we will come back. We will, having put it in a procedure, I can revisit that later. And that's fairly simple bit of functionality, but it's a nice little utility. Round down to okay. Let's try that. So in here, we're going to have to resize this frame before we build, and I will do that with frame operators. So we've got a resize for that. It needs a little bit of massaging of inputs to get that to work. We're going to rounding to, we want to work in units. We'll resize around the center for now. We can always change that. And then this amount is going to be, this is the thing we need to quantize in the X and Y. So we need to know what that value is as separate values. We can do that with dimensions here, and then we can make a new vector feed in there using this conversion. So if we just hook it up directly for now, and then switch everything over to use that, we should, in theory, not see any difference. It looks the same. But we can see if we disconnect and set our values, it is actually being used. So the Z, the vertical, we're not going to touch, but we are going to try. We do want to round. Let's just do the X first. So let's go with a step of 4. Yeah, so that's actually seems to have worked. Do another one of those for the Y. And now change the size. Yep. So you can see the outer bounds is changing gradually, but it's only using whole wall size segments. And just the other way as well. Yeah, that's the same. I think that gives us, at least we don't get the holes, even if we don't get to be as precise of the size we want. We're going to stick with the modular units effectively. That will, I'll have to revisit that in a minute when the corners are done, but we can deal with that. Maybe we'll look at that next. I will see. I think what I might do now, warmed up, is show you a kind of a work in progress feature that we've been building in Apparance for a while. We'll give it a go. I'm running a custom build here, so hopefully it won't break. Bit of a bleeding edge build. Yeah, so one of the things that's really useful with procedural objects is being able to, they have various parameters that you can change, like we've got the frame here, there's a seed here, it's the only other thing we're using at the moment, and that's it for the inputs, which correspond to the inputs of procedure here, the main procedure. But changing values in the property window or details window gets you so far, but it's actually much more powerful to be able to have in viewport editing of parameters. This was a feature that I've been working on for quite a long time, and it's still being iterated on. There's probably you'll see a few rough edges, but we're going to try it anyway. So one of the things that we can do is in here, if I go under edit operators, I'll need to turn on the experimental flag because it's an experimental feature. But we have a bunch of editing operators. Now, fundamentally, based around this edit mode operator here, which we can feed our content through, and by using that, we've enabled this smart editing button on the actor here. Now, what does that do? It's a very good question. And it straight out of the box, just doing this doesn't add anything. But with these other inputs here, particularly the handles one, we can start adding our own interactive editing functionality. I'm going to build it in a sub procedure, so I will add that here. Editing, all that. So handles, editing. What am I trying to say? Editing handles. Let's call it that. For a room. Let's do that. So just hook that up. What we're going to be adding, I'll start with a very simple example and then we can build on that. But basically you can add things called handles. I'm going to call this one move because it's going to be we're going to use it to move things around. It needs a bounds and it has some output. I'm going to build up gradually, so let's do that. A couple of here, you'll see why I need that in a minute. So that is an editing handle, but we won't be able to see anything unless we generate a thing for that. So a little bit more utility. I'm going to add another procedure here for a handle. So in editing handle, and that is going to just be generate a cube with a material. Do that. So I haven't covered any of the mesh generation functionality yet, but this is just a little taster, I guess. Ooh. Good question. So Null Pointer Games has asked how the Apparance XE and Unreal are linked. So yes, this is editor. The actual graph editor here is a separate application, and it does indeed have a localhost network socket connection to the running plugin. One of the reasons this was, there's a couple of reasons why it was designed like this, but one of them is that it means I can use exactly the same editor whether I'm connecting to Unreal or Unity, because there is a plugin version of the plugin for both, and all the same for operators and visual synthesis and stuff works on both. So rather than building it twice or building it custom within each engine's own UI system, it's built as a separate application. There's a few downsides to that, but there's also a few upsides as well. In theory, you can connect to any running instance of Apparance in any application, so you could connect to a console and fiddle with parameters and procedures whilst it was running on a console, that sort of thing. But yes, it's a standalone C# WPF app for managing and working with all the procedures. When you first open it, it connects, establishes your catalog, or pulls down your catalog of all the procedures you've created and all of the inbuilt operators that are available, and then it uses them to handle all the editing. There's no the representation on the editor side is different. It's all in C#. It's all set of classes that map to an equivalent set in the actual engine, which is all in C++. And yeah, some pretty basic network code to coordinate and manage those. An interesting aspect of that maybe is that changes you make in the editor are not made on the objects in the editor. They are turned into instructions sent into the engine. That change is made, and then the results of that are propagated back out to the editor. So that's why when you make a change, it's not always immediate. I mean, it's working quite fast now. We're on a fairly simple scene, and there's not much load on anything else going on. But for more complicated graphs and more complicated procedures and more complicated scenes, you can see a slight delay as you make a change and it goes sort of round trips. Anyway, I hope that answers your question. Probably a bit more information you needed. I could have just said yes. Another question. Can I define nodes as graphs and save them to disk so I can use them as collapsed nodes in other projects? So there's a couple of things there. The actual data is saved out by the engine on the device it's running on. So, but I mean, it's in the. I'll show you actually. It's in the Unreal project content procedures. So this that's an empty one. So this is the structure. You can see these top level categories are just folders, and we can see our main room is this procedure, and they're all just XML basically. Very, very simple. It's been like the format has been like this for pretty much ever. There's not a huge amount of actual information in a procedure. It's fairly basic. There is a proc-edit file alongside it, which is editor only data. You don't need that to run the procedure. You just need that for things like positions of nodes and all that sort of thing. So these files, to some degree, you can copy and paste into another project, but you obviously have to be careful of dependencies, because any reference between them, you need all the things you're referencing, otherwise it will just not load. There is another way of approach for this thing you can do. Anytime you've got two nodes, if you've got some stuff and you copy it to the clipboard, I just open this, you'll see it's in the clipboard in a very similar XML form, and then when you paste, you can paste that back in. So you could keep these snippets around as well, or store them somewhere. That might be another way of doing it. One of our team has built their own little management tool for that sort of stuff, for auto-generating certain procedures and administering some of this structure. That's kind of an interesting little side project they did. There will be more management features in the future. For now, this is the way it goes. Cool. Good questions. I'm going to carry on. So, as I was saying, a little bit, mostly at the moment, most of this project is going to be dealing with placing objects, which is using the place operator, this one here, where you resolve an asset and you tell it where to place it, and that's what we're using for all these pieces. But we also have functionality for generating geometry. Comes through into a procedural geometry component. And we'll do that for this cube, which we'll use for in a minute, will become clear. But basically what I want to do is set up a colored object. Right, I sneakily added a material here called handle, which we're going to use. And I'm going to add it into this main resource list. Oh, I already have. Look, there we go. Handle. So we can use that to refer to that material. I just wanted a semi-transparent coloured material. Already set that up. And we'll stick that ID descriptor in there. So create a cube, apply that material, set a colour, which I'm going to bring out. I'm also going to bring out. So the colour type in Apparance is normally only dealt with in terms of RGB. We'll set the default to white here, but it does have an alpha value in it. At the moment, you have to explicitly set that like so. And I'm just going to pull that out as a. So that's our 3 parameters. Basically, going to draw a semi-transparent handle. Do for the minute. I'm sorry, I'm just wondering whether or not I need to bother bringing that out. For now, we'll have all the handles looking the same. I'll do that in a minute. Okay, the reason I needed that was this handle we're creating, we won't be able to see. So when I put in this, again, it's going to be the same bounds, and it's going to be go with yellow and half opacity in there. So what happens now is if we have that selected and I turn that on, so turning this functionality on enables this editing panel. It doesn't have at the moment, it doesn't have much in it, so sorry, so we're not going to, I'm just going to hide that out of the way. It really just runs the smart editing functionality, and when you've got smart, oh hang on, I haven't hooked that up yet. We've created this editing procedure but not hooked it up, so let's put that in. It's going to have the same bounds as we had. We're going to have the actual full bounds, and we're going to stick that in there. There we go. So now we have this. Yeah, outer bounds is a highlighted box. At the moment it clashes slightly, so we'll just expand it a little bit to stop that. That won't matter too much. Do that. I'm just going to this. So I will just do a cheeky little extra amount in axis. There you go. That stopped the flickering. Another thing is it's on all the time, but we can actually use this highlight output here to turn off the visuals when it's not highlighted, because highlighting is a thing. Do that. So that's the conditional content, and now it's only highlighted when I point at it, which is how the handles work. Go back here. So to get it to actually do something, we've got these inputs here. These are list inputs. There's a list type, which is kind of dynamically or loosely typed collections of data. That can include sub lists, So you can use them like structures, or it could be values like floats or vectors. But what we're going to do here, these have special use cases, and there's a couple of particular things we can do. There's various editing functionality we can add in, but to start with, we're just going to do entity move, and that's the, I'm going to put that in drag and set that X and Y to 1, because that's the axis we want to work in. Now, fingers crossed, if I drag, it moves it. So we now have an editing handle where we can move our objects. Right, that's a very basic example. Let's get in a bit more depth and allow us to resize it. And the reason I'm kind of going to do this is because as we develop this base station room, it's going to be nice to have multiple ones working together and build out some sort of space station, eventually dealing with things like doorways and corridors and interconnections. So I just thought it'd be nice to have a bit more intuitive way of working with these things. Otherwise, we're down to the traditional Unreal handles and changing values in here, nice things. So let's look at the we'll look at the resizing next, which is a bit more complicated. But before we do that, I'm going to add a couple more rooms so we've got a few more objects to play with. And the way I'm going to do that, I could just drag in a new entity right here, set the procedure to room, give it a size, and then we have a new object. But that's a bit fiddly. So what we're going to do instead is create create an asset called a entity preset. It's going to be room. Now that, if I open that, it looks a bit like it looks a bit like the property window here, but it's more slightly abstract. It's just an asset. It's not actually in the scene. But we can set a procedure. We can set some default parameters. I'm going to go with 884, and that should give us a small-ish space station room. Don't need that now. Now these you can drag in, drop down, and you get a room. So, yeah, slight bit of, yeah. So again, we can move them as we would normally. We can resize them if we want, but we should be able to smart edit them as well. So they'll any selected one. As I said, work in progress. I don't think it likes new ones yet. So that one's working. That one's working. We'll deal with those. So I can grab that and move it around. That's flickering. Let me fix that. So in here, I don't think it uses mesh instancing by default. We'll say add that in. Oh, it hasn't inherited it. Hang on. There we go. There we go. That's better. And then this one should do the same. That was our original one. It's fine. This one still not happy with being smart edited, so we'll come back to that one. So let's look at sizing. We can move it around. How do we add sizing? What I might do, because we'll still have this handle for moving, I'm going to move it to the top. And see that in a minute. So what I'll do is split that out. We take the top of tiny amount. So that's splitting the frame in the z-axis by 0.1 units, like 10 centimeters. And I've inverted it so that the 10 centimeters is the remainder, the top, the upper part of it. If I move all these over to here, you can see that we now have a handle on the top, but not on the sides. We're going to use this. We're going to put handles on the sides to drag them and change the size. How are we doing? Oh, that's good. Right. Look at that next. I'm going to just construct it all in here. It's going to be fairly leave that over here because we need the rest for the other handles. So this bit, show you a little feature. If I do that, we can add a little note. Is move X, Y. And that's now a little group we can keep separate. Let me look at this. Right, so we're going to put handles on the sides. Let's start with the right hand side. Is the positive X. Similarly to the walls where we split off using a shrink, we can do that again here. That remainder by, again, we'll just do 0.1 units in the X direction. But we want to shrink by that amount. So the lower and upper outputs here are going to be the edges. They're going to be the edges of the frame. And then very similar to this lot over here, I think pretty much going to be the same. I'm going to duplicate that. We could put it in a procedure. I'll leave that as an exercise for the user. We're going to do a size right. So each handle needs a different name to keep them identified separately. And instead of being the whole bounds, we're just going to use this upper part here, in there. I haven't put the functionality in yet. We'll do that in a sec. We should now have two handles that we can get hit tested and select. But unlike this one, which has got functionality, this one doesn't do anything. So, which ones do we use for that? Called frame size, I think. There are some complexities we'll hit in a minute, which I will cover, but basically we're trying to change the size of this. Right, this is where it gets slightly different. The world transform of an entity is part of the engine functionality, and that's not a property coming into our procedure. The procedure doesn't, the entity doesn't actually know where it is in the world when it's building the procedure. It just goes by the inputs. So the bounds you get in here is actor relative, which is why you can just move them around and it doesn't do anything special. So this move functionality here isn't doing anything with the procedure at all. It's just moving the actor, and that's why it's got its own special interaction functionality. When we are resizing, we are actually wanting to change this input parameter, and that's why this operator has a parameter name in input. So we need to set that to be the same, because this is the parameter we want to edit, i.e. its own bounds input. And we'll deal with the rest in a minute, but in theory, just hooking that up to the drag means I should be able to oh, hang on, nope. Where have we gone? Bounds parameter, amount, X. Yeah, why doesn't that work? X is, oh, I know why. Is working, I think. Maybe? Not working. You could see the value changing. Okay. You can change it explicitly. Why not change it? What am I missing? Maybe I've got the wrong. I'm pretty sure that's right. X-axis. There are some known bugs. I wonder if it's related to that. Try from a couple of different directions, and also try that. Right. Next thing to try, I'm going to do some visualization. Let's put the frame in so we can see the exact bounds. All that there. Oh no, I need to do that on the main. Yes, anything. Okay, some investigation required. I don't need that. Do here. That's right. Bounds. Click Drag. Pounds. Need that. Try that. Oh, hello. Where did you come from? You were over here. What's going on? Hmm. Oh, hang on. Is it relative to the... No. So I tried this before the stream and it was working. What have I done differently? Let's implement the other axis and see what happens. Right, let's do it from scratch. Box handle, gonna merge two together. This is going to be back, lower edge, handle. Highlighted. This seems to be working, these bits. Showing the handle, highlighting it, that sort of thing. And now we should have one on this side. Nope. Where do we go? Ah, hang on. Oh, that's not the... That's the left. Go left. So that's this side. We've got the handle on this side. No functionality. We'll check the actual... Modify the size of procedure as frame parameter. Yeah, that's the one. Frame parameter. It's called bounds. Drag. Operation. Yeah, that's not. Let me just check in the debugger what's going on. It does say failed applying editing action. Wonder if this. Why is that thing? Okay, that's annoying. I don't know why that is. I might have to come back to that. That's a shame because we were going to be able to resize them. It's probably something fairly straightforward, but rather than dwell on it, I might go and do something else. Come back to it when I have some insight, so it's not so we don't get bored viewers. Okay, I'm gonna go and disconnect. Oh, no, not that. I want to disconnect the frame. Just leave that. Turn off that, and we're back to here. Yeah, it's still building fine. Let's go and look at these corners. Let's put those. Yeah, probably not going to get onto the floor today, but that's okay. Plenty of opportunity to look at that. Okay, let's save the level and look at the assets we have. Okay. Right, this is the asset kit. What we, in the demo map, I think it was one of these pieces was used in the corner. This one as a filler. I don't think it quite fits though, so we might have to do some jiggery pokery to get that to work. But we do need to refer to it. Not sure exactly where these are, other than maybe doorways or making things more interesting. I've seen this one used to make the walls a bit more interesting, but we'll come back to that. Might be able to use that in a corner. We'll see. I think this is going to be our corner piece. I can double check because there's a in the double map. Excuse me, in the demo map. Let's have a look. Yes, so that's the piece we were just looking at. I'm pretty sure is column B. They use that in places to make the walls more varied, but we'll come back to that. Oh, that's a divider. Oh, interesting. Yeah, we'll have to look at that as well. Make the Oh, they use it on every piece. But there's this aligns with these dividers to make the room like a room partition. Interesting. Lots of interesting complexities we could add. Oh well, it's things to build up towards, but let's get this corner working. Go back to our demo map. Right, station resources. So we need a lookup for the corner piece. So we've got floor, wall top, bottom. I'm just going to add here as corner. I'm going to make it have variance in case we want to add more, but initially what we're going to do is wall corner. Let's do it down here. Column B. Yes, it's a column. Maybe we should call these columns. No. This is call them corners because we can always have columns as another thing and still have this in both. That's fine. It gives us more. The intent is clearer if it's labeled as corner. So this is the resource mapping table, Apparance asset type, and it allows us to map from identifiers in the procedures into actual engine assets. Procedures don't really know anything about. Do that. I've copied the identifier here, and I'm now placing it. What I will do, what I normally do, is I'll wrap that in a procedure of its own in case there's any wrangling needed, which can go with it. Separate, more of a wall thing. Maybe we'll do wall, do it under wall. So I'll do wall corner piece of a corner of a room, I guess. And in there, much like we did before, I will do it. I'll redo it. I won't copy it from before. We are resolving with our descriptor. There's only one variant. We'll just stick that there, and we'll place it in the scene wherever we've asked it placed. That's it for now. But there's a couple of things I need to do here. So our main room at the moment, we've got this bit over here, which is our size snapping. So that's making sure we're in units multiples of 4. We're chopping off 4 sides to place the 4 walls. What we also need to do is effectively chop off the corners first. So there's a couple of ways of doing that. It's kind of a 9 slice, if you've heard of that with user interface. It's used where a texture is sliced up into 9, and then those 9 pieces are mapped onto triangles so that as you resize it, it doesn't stretch the outer parts, it only stretches the sides and the center. Similar idea, because with a room we want the walls to stay the same thickness, but as we resize, the content and the wall itself is stretched in the sense that it's made longer out of the same pieces. There's different techniques for how they're actually applied. But so we've got 4 sides, 4 corners, and the remainder in the middle. So we should. That's a bit of functionality that is quite useful. So I might make a procedure for that. Let's do that. I will kind of a utility, so I'll put it down here. I'll call it working with frames, and let's do work 9. Another question: do you need to predefine and mark up the edges of the 9 slice parts? Not quite sure what you mean. So this asset pack has certain modular pieces which have certain sizes and conventions as to how they've been built. If I had the luxury of having an artist to make the pieces for me, I might make slightly different decisions about how the modularity works. This has been fairly sensible so far. It's based around a unit grid with lots of pieces being 1 or 2 or 3 or 4 units in size, which helps with the positioning and the snapping. They seem to have been fairly carefully built, which is nice. Sometimes it's less of a luxury for that. So in the actual procedures, if for example I have obtained this corner and I'm going to place it somewhere, I do need to know how big a space I'm going to put it in. And now that could be hard coded, and I'm probably going to do that in this case, or it can be based around the actual asset dimensions, the original dimensions, which is where this bounds input is used. I could show that actually, because you don't have to. You could use this operator somewhere else purely just to get the dimensions. So we might do that. Yeah, let's do that. But I'll see that in a minute. And that will give us some aspect of our nine slicing. Yeah, there's a little complexity in here in that the walls are bowed, and the bottom comes in slightly shorter than the top, so there's a bit more overhang on the top than the bottom, which adds a bit of complexity. The corner pieces aren't as big as this full size here. We could make them, I suppose. We could just whack it in there and scale it up slightly. We'll play with that in a minute, so we'll see how it goes. Does that answer the question, I wonder? Do you need... Right, I guess one of the things I'm skipping over is that when you place an asset with this operator here, the frame you give it is the frame that the... I can show you exactly that. If I just drop in a... oh, I did. Hang on. Oh, yeah, there it is. If I drop one in as corner, there we go. You can see it's the default size of 1 unit. It has... Right. Good question. So these are fairly... So the question is about the fundamental size of a piece, regardless of any extra bits that stick out, I think. As you can see here, we've placed this column in a unit cube, which is not sitting right on the thing. There you go. And the design of this column is that it does meet that edge, or it appears to meet that edge pretty accurately. So if I say put it in this meter cube, maybe you want it a bit taller. There you go. That's my column. The design of the mesh means it will fit exactly because we scale the mesh using the bounds of the mesh. There are, if this had pieces sticking out, that would complicate things because the apparent size of that object, like your example of foliage sticking out, it doesn't fit in the bounding box. Yes, so what it would do, it would assume it was bigger than it actually is. I don't know if we've got any good examples of that, but I'd have to have a look through the assets. I mean, these are all fairly. I mean, some of this stuff is. I suppose the walls already do it, where they have different size pieces sticking into the room. But what we've done is we've aligned to the back edge and used the whatever size the asset is. We covered this in the first stream actually, which means it will build out to the correct depth, but it will always align because it's built out of the. They have a common back line. Some assets that isn't going to be true of. I mean, we tried to use this as a column. We might have a problem like, oh, this has got a nice column aspect to it that we want to use, but it's got these pieces sticking out. So as a column, it would appear wider and have this hole. So there's different ways of dealing with that. One is to hard code it. If you know it's a particular size bounding box, you can say when I'm placing it, I need it to be bigger, and I'll resize it. The other thing to do is in the mapping table here, where we've got, for example, do this here. So this corner we've got, up a bit. This corner we've got is this column. If I change that to be that, you can see already see that the problem a bit. So this has squished it because we've told it to be a meter by a meter. But what we can actually, there's a couple of ways of fixing that if we wanted the column part to fit in this space. So that in amongst the details of each asset, there are different things we can do. We can specify the bounds explicitly, like custom. So we could say the bounds is, let's have a look. That's 87.5. Oh, that's the center, sorry. It's 112. Yeah, so it's 112 by 50 by 5. So it's actually, the core part of it is actually 50 by 50. If we tell it just to use that bounds there, that will correct for it roughly. And it will still think it's small. If we placed, we can fix the alignment in the placing, but that's one way of doing it. Another way is by specifying a mesh. Go back. Hang on. By specifying a mesh, and we can actually think. We pointed it at that. So that's going to use the bounds of the actual column-shaped column as the bounds for this column. May or may not align, but again, we can do different alignment things if we needed to. So there's various ways of fixing up things. We'll go back to the original here. What else can you do? Yeah, there's controls over how things are placed as well. So we could have unscaled, which means it doesn't try and scale it to fit. We can just let it none, which means it just places it at the same position, which again has different results. For what we're doing, we're going to just do this though. I will be going back to the original. We'll work with this one for now. Let's have a look at that and see how we get on. Modules, multiples, step sizes. I'm going to touch on some of that with the floor because if we look at, so I've been asked, and we also have modules that are multiple of step sizes. So in here you can see these floor pieces have all sorts of different sizes. Now it adds an interesting complexity to placement when you're trying to fill off space with all sorts of different size pieces, but they are modular and based around a unit size. So we've got 1s, 2s, 3s, 4s. Oh, I haven't got any 3s. I think they're 4 by 1. Yeah, so it's 1, 2, and 4 are the other factors we can use. And it's something I was going to cover in today's stream, but I'm probably not going to get time now. But that's not anyone's fault. We've just done a lot of stuff. So next time I'll look at that, and some potential techniques. Yeah, that's fine. So there's some techniques that I was going to demonstrate and show to do with subdividing spaces and making choices about use of assets. And so what I'd do for here is I'd have floor categories in the resource list for a floor 1 by 1, a floor 2 by 2, floor 1 by 2, floor whatever, all the different types, and then each of those could have the variants in. So there'd be these maybe these 3 pieces would be in the 1 by 1. There'd only be 1 2 by 2. There's a couple of 2 by 1s would be in a group together, and that means we can ask for an asset by a certain size, but not really care about which variation it is. And we can do things to control how those variants are used to make it to do some nice patterning, and regularity. But we'll probably just start with a random version. But more of the problem is deciding how to then use these different shapes to fill the space available. Because at the moment we've got the fairly straightforward floor made out of these tiles, which was an initial step. But I want to use all of these pieces. And we can also look at these pieces here, which have an interesting use case, which is for doing like rectangular boundaries around areas of floors. We've got a corner and a couple of different straight pieces. So I might look at how we can use that as well and incorporate that in a floor layout. These are techniques I've used in a couple of different places, most notably possibly the procedural gardens, like ornamental gardens with lots of space dividing and choosing of how to split it up to make regular patterns. So that's something we'll look at next time. So I'm going to go back and finish in this column in the corner, and that might be enough for today, but we'll see how we go. Let's go back to that. Right. As I said, we have a corner. Need that there. What we do need is to get our room split up again. Corner. Oh yeah, we just create that. Oh. Okay. Do that. Yeah, I'm going to rename it slightly. XY, because we're only doing this split in the 9 slices of 2D concept, so I'm going to press that it is in the ground plane. XY. We have some. It's not going to be very complicated. Procedure. We have an operator we can use for most of the heavy lifting, and that's to shrink. We've seen before. We've used it to cut the edges off, which is what we're doing here. But we also want to generate the corners as well, and the sides will be inset. So there's a bit more to it than before, but pretty much chop it down in one axis by an amount. So our amount parameter is going to be the amount the border of this 9 slice is going to be, the size in absolute units. That's why we're using units. We'll do it by X first, and that will give us this whole left edge and the right edge and the whole center, including these bits. We then need to shrink each of these pieces again. I think, yes, that'll end up with 9. So we've got, this time we'll be doing it in Y, the same amount. Yeah, so do 3 of those, 1 for each. That gives us our 9 outputs. There's going to be some subtlety to this, which we'll come to in a minute, to do with the orientation of each piece, because at the moment all of these inherit the orientation of the original. We can retrofit this into the main room, but we'll have to redo some fixing. It's probably worth doing the fixing in here, because then this is a bit more of a reusable piece of functionality. So what I do need is, obviously I need all these as outputs. Drag all those out. We'll give them sensible names in a second. Well, possibly the simplest is the. Hang on. Let's start at the top. So on X first, and we're on the lower side, so we've got the lower corner, which is going to be. I'm going to mix my metaphors here. This is going to be the southwest corner, just because it's an understood convention. That means then we'll have the west side, and we'll have the northwest side, and then we're going to have the north side. Now this is probably the simplest one. This is the whole centerpiece, the inside of the whole slice. South, and then the right side will be south, east, east, and northeast. There you go. So that's kind of a nice convention to use sometimes for that sort of split. Right, let's go back to the main. So instead of doing these two shrinks here, what we can do is bring in our new 9 slice. I'm going to set the amount. At the moment, I'm just going to set it to 1, and we'll carry on with that in a minute. I might visualize some bits so you can see what's going on. Right, so I will increase that just for clarity. So that's the centerpiece. It's chopped out. We can go through them in turn actually and show you what it's actually done. Let's have a look. So we've got the southwest corner, that's down here, west side, northwest, north. Oh, no, that's south. I got that backwards. Is that right? Have a look. Yeah, that's south side. Got my wires crossed. Let's go back in. Oh yeah, lower north side. What I'm going to do is rename those because that's actually right. South side, yes. Center we did. North side is over there. Southeast, east, and northeast. Yeah, so that's good. Means instead of doing these shrinks for the walls, we can do. So the equivalent before was the lower X side is west side, so we'll take that. That is now there. We notice that it has brought it in by because we're now 9 slicing, the corners are separate and the wall will only get built in that up there. So that's good. And we'll do the same with the other side. Now I'm going to remove both of these. So we've got reintroduced the problem where this is the wrong way around, that it's inheriting the original orientation. So I'm going to basically, we did it explicitly here, but what I'm going to probably do is just steal that, put it in here as the east side reorientation, which means whenever we do the 9 slice, we'll get oriented pieces that kind of make sense. The corners are a little bit more tricky, but we'll come back to that. So let's do the top and bottom. Don't need that shrink anymore. So instead of shrinking on the Y, the lower side is going to be the south side, which is that one, and that's going to be the north side, which is that one. Again, I've bypassed the reorient. We're going to steal that for the south side. So the north side has worked. Nope, same problem. We need to bypass that. Okay, neither side works. We need these orientations. This one was the south side, so let's put that into here. Incorporate it in. South side. There. That bit. Yep, that's the south side. We also want one which we're going to put on the north side. So we don't need to do it on the west side because that happens to match. Now we have our walls with the corners gaps left. So that's where we can put our corner pieces. Do that next. So that has simplified things in here. We don't need that anymore. We're doing it all in here. Way. So we've got our could label them. Another little feature, useful. Okay, you can add little comments. So this is the rest wall, east wall, wall, north wall. It's a bit easier to track. Might leave those together because the walls all live together. Now, so what we could do, we could try the floor on the center. There you go. So the floor is now built in the center, but well, we've got it set to 2 units in, which is wrong for the floor, but we'll do a couple of things we could do there. Leave it out. Go back to where it was. Doing good. Few people watching. Welcome to the stream. I'm going to try and stream every week, but I am on holiday next week, so there won't be a stream. But I will be back the week after and be back to maintain cadence. Maybe I'll post some other useful bits and pieces you could have a look at in the meantime. There's lots of stuff on the website, showcases, demos, things like that. Or we'll see. Right, let us do the corners. So I've got this. We had a corner procedure, which here, in theory, I can just say, let's have the southwest corner. Let's hook it up and see what happens. Wow, look at that! Bang, we have a corner. It's obviously quite large because we've set it to 2 units. Let's just reduce it down to. No, that's not a bit more than 1. Just set it. So we can play with it while we're here. Right. We've got it set to 2. 1. What would that look like? Okay, a couple of things have happened. One, the pillar is 1, but we're now no longer a whole number of wall pieces, so it's not filled out, which was something we talked about earlier. We're also not meeting this corner, so these are going to overlap. Let us make it a bit bigger. May or may not cause problems forward, but we'll try it. Let's go 1.5. There's going off grid. Better. And they've chosen not to fit on the grid. See, the bottom might be 1. I don't know. Right, what we can do here. So this, now that we're 9 slicing it, this is not going to. Our original quantization of the size doesn't apply. We can correct for that by taking off our corner size, quantizing it, and then adding it back on. I think we'll do that as a sort of quick-ish fix. Oh, the other thing I was going to do was actually try and use the original pillar size, wasn't I? If I go to the corner here, take that out here. What I'm going to do, so this is going to resolve the corner piece that we had. We're going to get the bounds, and I'll just use the X size and see what that does. They have so its original size is actually shorter, and that's how it would look. I mean, on this asset, it's quite shiny and clean, so having it a bit of a different size, a bit of scaling, doesn't really spoil the effect. If it was a textured thing, like with more obvious texture and surface, it might do. But for this, I think we might get away with just having it explicitly sized. So let's see if we can work out what the actual size is. .27 is too big. Oh, it's 1.25. Oh, there you go. That looks likely. I'm going to go with that. a bit neater. Let's do that. Still need to fix this problem, so let's do that. And we'll leave that at fixed size for now. To work with the size of the wall panels quite well. So this is our original rounding. Take the bounds we're trying to fit, we round it and we use that for the actual size. But instead, what we're going to do, we need this number somewhere else. So rather than type it in twice, I'm actually going to set it up as a constant. These are a bit odd, but they're basically really handy. You can use them as through connectors, but you can use them also as shared constant values. And we can do, let's label it as well. This is the size. So what we need to do here for these is take off 2 corners, round it, and then add 2 corners back on. I think that's what we need to do. So let's try that. What we might be simplest to do is just, we're going to need that number twice. This double twice. We'll just create that there, and we'll subtract it from here. We also need to add it. Like so. And there have. So as I resize this, you could see only allow sizes that where all those pieces fit together nicely. We've only got 1 corner done. Let's do the others. Very straightforward. Now this asset is kind of has an orientation. It's got the interesting side here, which means in this case it works without any reorientation, but I might probably do is use that as the reference and then have the others rotated to match. That in a sec. Smaller for a minute. Oh, not that small. No. Do that so we can see everything down here. Right, so that's that fixed. Have 1 corner. I'm gonna 4 here, and we need each 4 corner spaces to be used. So we have our corners, but as we can see, hello, like that. Oh, it's just there. That one, which way around are we? That one's the correct one. I mean, they look okay, they just look different. I think it would be better to have them all match, so we're going to rotate them all to look like that. Means, so northwest corner. Go and do that one first. We'll do it in here, because I want to be reusable. Reorient. So northwest corner here. Nothing. So what rotation do we want there? -1. There you go. Good. We'll go with that. The east corner is down here. We're going to need, let me guess, 2. Correct. There you go. That's a 180 turn. They now match. Now just the other corner. Which is southeast. Now by process of elimination, that should be 1. Correct. Now this procedure's got a bit messed up with the bounds, we can actually reset that to make it a bit tidier. Out again. Do that. That'll do. Right, we have corners. They're neatly placed. They're all aligned. And if I change the size, fit nicely. Right, I think that's going to be enough for today. We don't seem to have changed an awful lot. Let me reconnect the roof. Plug that back in here. Still got our very similar room. It's got corners now. Everything, walls are aligned and don't overlap. Floor needs to do. Oh, I could do that quickly. So the floor, yeah, it's not going to be straightforward, is it? I'm sure we'll come back to that next time. Okay, so we did play with the handles, editing handles. They are being a bit temperamental. I'll see if I can fix that for next time. Move stuff. How we size stuff? Question. I think I missed something. I'll get that working. We can cover that next time and finish that off. The layout has got a bit more robust. We don't have any gaps. It's all nicely aligned. Done a little 9-slice utility procedure. Add things up in here. I think that will do. Any questions before we finish? But as I said, I'm going to try and be streaming every week. But this week, next week, I am away, so I will not be. And then I'll be back. Let you know. I'll post once this is finished. I will get it uploaded, and you can look back through it if you want to. I was booked ages ago, Dan. I don't really fancy lugging my PC and all my equipment to Cornwall, but hey, I did contemplate it, but no, I'm going to have an actual break for a change. Okay, thank you for coming, and spread the word if you know people are interested in Proc-Gen or space stations. Then let them know that I'm doing this stream. Kind of pretty low-level nuts and bolts stuff, but it's all the day-to-day bits and pieces that has to happen to make things. So I'm sure you know game dev streams are a bit like that, but hopefully this is a bit more visually exciting. Thank you. Okay, I will see you next time. I should address the camera more. Hello, bye.